Well, I'm going to get started here. 2.1 is on linear equations. So equations with one variable, and we solve those by basically doing order of operations backwards. So we undo addition or subtraction first, and then we undo multiplication or division, the goal being to isolate your variable. Sometimes we have fractions or decimals to take care of, and so I'll show you how to do that. We can add or subtract terms so that we can get the ones with variables on the same side. So I'm going to work out a few examples and do that for each of the sections. And if there's extra questions, feel free to interrupt me or ask for clarification. So here's an example where we have variables on both sides. So let's get it on the same side. You can get on the right or the left side. I typically get on the left because then it's going to end up being x is this or m is this. It's easier for us to understand. So now I'm going to get the number, the constant, on the other side. So again, I'm doing my addition or subtraction first. And now I'm left with multiplication. It's -2 times x. So to undo multiplication, you do division. A negative divided by a negative is positive. The negatives cancel out, leaving you with 3 in this case. I'm not going to work through every example, but I'll give you a couple tips on them. On number 2, that you distribute the negative as well. And with fractions, you can clear them and work with integers by multiplying by a power of 10. So in this case, I have 2 decimal places, so if I multiply by 100, I move the decimal 2 places, and it's no longer a decimal. So whatever I do to one side, I do to the other. So here's one method, is multiply each thing, so both sides. Here you're doing the distributive property. So you'd have 15x minus 2 places over 40 equals 2 places over 20. From there, undo your addition or subtraction first. So adding 4. And then dividing by 15. So that's the decimals. And then to work out one with a fraction, oops, the thing just, there we go. You look at the lowest common denominator. So 4, 6, and 3. And the lowest common denominator is, when you count by 4s, count by 6s and 3s, the lowest common multiple. So 4, 8, 12, 6, 12, 3, 6, 9, 12. The lowest common would be 12. And again, I distribute that to each side, and so to each term. It's easiest, in my opinion, to write it next to each term. That way you don't make mistakes with your fractions. So 4 goes into 12, or you can do 12 times 3 divided by 4. Cross canceling is my preferred way. So 12 divided by 4 is 3. 3 times 3 is 9. That goes in 2 times. That goes in 4 times. And so you've converted a problem that has fractions where you would need to get common denominators to add or subtract, and then you need to do multiply by a reciprocal to undo a fraction. This is a lot nicer in that you're now just dealing with integers. So adding 2 and dividing by 9. And do leave your answers as improper fractions. Let me bring this down just a little bit. Not as mixed numbers. So are there any questions right now about linear equations? I want to just make sure, Carly, you can hear me? And Jennifer, can you hear me? I do want to mention a little bit about some special cases with these. So if you work this one out, doing the distributive property, to simplify the right-hand side, the left-hand side, you end up with 6x plus 21 equals 6x plus 7. If you then try to get x's on one side, you'll discover that you have no more x's. They cancel out, and you're left with a false statement. 21 does not equal 7. And so that's when a false statement occurs. In the special cases of no solution and infinitely many solutions or all real numbers happens when your variable cancels out. And you'll see that also with systems of equations. So here again, distributing. Combining like terms. 4x plus 7, and here we really have 4x plus 7 as well. Oh, my thing got in the way. 4x plus 7 equals 7 plus 4x. That could also be written as 4x plus 7, and so they are the exact same statement. And again, if we continue, we end up with a true statement. And so everything that you put in for x would work, versus the no solution, nothing that you put in for the x would work. So that's your special cases. Any questions about those? Okay, so let's take a look at the computer for a moment. I wanted to go through 2.1 and give you a few little tips, and if you have any questions, let me know. So 2.1 that we just talked about has a couple videos that you can watch as well. And in the homework, I want to make sure that if you guys have any questions on how to use the system, that you let me know. Please note that on these, there's sometimes stuff outside, and so you wouldn't say y equals inside. Also note that when you click in here, there's a yellow arrow that gives you some functions to enter things a little bit easier than doing it with your keyboard sometimes. Sometimes your keyboard's easier. The preview is important too, because it makes sure that what you wanted to enter is what's showing up. The tips also are important to pay attention to in case you're not sure how to enter a certain thing in, what format they want, that kind of thing. There's the video that's similar to this, and this is the link to the ebook section, 2.1. As you go, you're submitting. You can always, if you get it wrong, let's just make a wrong answer, and then let's make another wrong answer. That second attempt. And then you have your third attempt. Again, I'll just do another wrong one. It'll tell you the answer, and so sometimes that can help you work backwards or figure it out. Sometimes they even have a worked out one. Then what you do is you hit try another similar question, and you get a similar one so you can get your full credit if you get that correct. So I just want to make sure everyone realizes you can always get full credit on questions. You just have to hit that button at the top that says try a similar one. So I'm going to go to this print version, which might be helpful for some of you to print it out while you want to work on it, and have the problem right there to not have to write onto a piece of binder paper, or you might want to do it while you're not having computer access. Here you can see, like the problem I talked about, make sure you distribute a negative. Here's some work with decimals. You can first distribute the decimals and then deal with multiplying by 100. You can also distribute first, or you can just multiply by the LCD of 6 for a problem like that. And here's those special cases that I was just talking about, where once you solve for it, if you get a true statement with no x's, then it's infinitely many solutions. If you get a false statement with no x, then there's no solution. Linear equations will always have one. X is this. Quadratics, things that have an x squared, would have 2 solutions. So we're not going to have any with 2 solutions in this lesson. There's some word problems. Those are always a little bit trickier for students in general, especially if you don't understand the context. So please make sure that you let me know if you need any help with that. And they are meant to be sort of more of a challenge problem. Every lesson has a couple problems that are a little bit harder. All right, so I'm going to go back now to the lesson on 2.2. Please interrupt me if you guys have any questions. Okay. So 2.2 is on formulas. Sometimes it's called literal equations when you look for it online. So first off, there's going to be a few questions where it asks to find a value of something, evaluate it. So it literally means plug in what you know and simplify. So then there's the other half of the assignment is where you're solving for a particular variable. So solve for y, or solve for r, or solve for t, or whatever it might be. In this case, here's a formula: distance equals rate times time. And if we want to solve for r, we need to get rid of the t. Well, the t is being multiplied, so we undo it by division. So we have d divided by t equals r. The rate is your distance divided by your time. So if you go 60 miles and it takes an hour, which is, by the way, 60 minutes, you can say, well, I go 1 mile per minute. It's a rate. It is a rate of speed. I'm not used to this particular projector thing, so please let me know if you can't see something and you want to. All right, so let's do a few more of these. So this one is circumference. Oops. Where did that go? There it is. Let me get this out of the way. There we go. Circumference equals 2 pi r. And it says to solve for pi. So we want to get rid of the multiplication of 2 and r so we can divide. So pi is the circumference divided by twice the radius, or the circumference divided by a diameter, and that is what pi is. What What about if there's addition or subtraction as well as multiplication? So again, you basically undo your addition or subtraction, then undo your multiplication or division, just like you would solve for any other variable. You just keep that there. So those are not like terms, so we cannot combine them. So we just write 6 minus 2x, or you can write negative 2x plus 6. And getting y by itself, we're going to divide by negative 3. We did it to this side, so we're going to do this to the whole right-hand side. Both these terms are being divided by negative 3. So we get negative 2. Negative divided by negative is positive. And you can leave it in that format, or if you prefer, you can put it into y equals mx plus b form if you want to think of it kind of as a line. And this is actually the process you're going to do later on, going from standard form for a line to slope intercept. Again, either one of these works. Let's look at this one here. Let's get caught in the cord. Solve for g. So we want to get g by itself. So we're going to first undo addition or subtraction. And then we'll undo the multiplication. You could also divide both of those by 2 and write it like that. I'm going to do one more of these, unless you guys want additional practice problems. Solve for v. So v is in the denominator. So we need to get it to be a numerator. So I'm going to multiply both sides by v. Gets rid of it in the denominator there. So to undo division, you do multiplication. And then we want to get rid of the multiplication here by d. To get v by itself, we divide by d then. So v equals m over d. All right, any questions about 2.2 that I can help you guys with?
You're still hungry. I can see more in 30 seconds. I'll be right back. Some more.
What is your question, Jennifer, about the calculator?
Can you hear me okay?
Yes.
Okay, so I have the TI-84 and I just wanted to see if I should invest in the 89 or if that will be sufficient.
So it kind of depends on what class you're taking. Are you going on to the STEM track, like doing trig and pre-calc and calc and all that?
No, my next and my last class for math will be statistics.
Okay, so the 84 is better for that class. And
Okay.
so in 80, we have the official one is the 89 because it really is more of a STEM track class to be an 80. But I have no problem with you using the 84 or the 89. You're just going to have to adjust the directions and maybe look up some more videos to help you with some of the assignments.
Okay, I can do that.
But
thank you.
I'm very comfortable with the 84 and 89 or 84, and I may even post a few videos to help you guys out because that's actually my preferred calculator.
Okay. Oh, okay. All right. Awesome. Thank you.
Any questions about 2.1 or 2.2 at this point?
Not for me. I haven't like gotten into it quite yet, but watching like this will be review for me, and it's all looking very familiar. So
Good.
I'm good. Yeah.
Okay. I was realizing you were texting me at first, and the chat was not popped up when I'm showing this. So I'll see if I can't have both kind of going at the same time.
Oh yeah, no, that's fine. Just the last class I had, it was mostly text, but that's totally fine. I wasn't sure.
You are welcome to do either one. There was a way where I could see it on the side, but I don't know if with the document camera it's the same as yesterday. I wasn't using the document, or last time I wasn't using the document camera. So let's.
Oh, okay.
Let's see, Carly, did you have any questions? I guess you said not yet. I think that was for this section. Okay. So let's look at 2.3, and this one is probably the most challenging for most people. And that's the ones that are word problems. There's, examples in your textbook, but it's nice to actually walk through them as well. You'll notice in the textbook they often use X and Y and Z. Sometimes I find it easier to use letters that represent the situation, like W for width or L for length. So let's take a look at, let's take a look at this first problem here. It says, the length of a rectangle is 3 inches less than twice the width. And I'm going to see if I can get this to stay without falling again. So I draw a picture, and I, again, normally say width and length rather than using X's. It really doesn't want to stay up. Let me find a book to prop it up on. Okay, so it says the length is, and is in math is an equal sign, 3 less than twice the width, and I'll use W for the width. And so when you see less than, you need to know what you're taking it from. So it says twice the width, so that's 2W. And then it says 3 less than that, so then I can subtract 3. So the length is 3 less than twice, so 3 less than twice. And I always go back and check that my statement and what I've written down algebraically match up. You're going to need to come to these problems with a little bit of prior knowledge, and that prior knowledge is often actually in the book. So for example, the perimeter of a rectangle is 2 lengths plus 2 widths. Perimeter is where you're going around the outside, so you have 2 lengths and you have 2 widths. And when we do others, I'll mention some other formulas you kind of have to come to the table with or look up to see the relationship. So the perimeter is 45, so I can replace the perimeter with 45. And I have 2 lengths, and the length is, and I'm not going to write the L anymore. I'm going to try to get this expression only have one unknown. So instead of writing L, I can say, well, L is this, so I can write this in for the L. So it's substituting it in. And then distribute and solve from there. Combine like terms, simplify that right-hand side. Undo addition or subtraction. Undo your multiplication by dividing. And 51 divided by 6 can reduce, but it cannot it's not a whole number. Right, as a decimal or a fraction. If you're going to do a decimal, make sure it's not just, you be careful with rounding. So if this is exactly, let's see, actually it's, let's see. Yes. It's exactly 8.5, and so it's okay to write it with a decimal. But if it had been like 51 divided by, actually let's pick a different one. Let's say it was 7 divided by 3, that would not have terminated, so you would have rounded, so that wouldn't have been good. You want to leave it in this fractional form instead. Okay, and then once you have your width, you often are asked also for the length, the other dimension. So go back to your original thing. It says length is this, and plug it in. Earlier today, I had a student that asked where to plug things in. They were able to find the width, but not the length. And so they asked if it was possible to plug it back into the 45 equals 2L plus 2W. And you can do that as well, and you'll get the same answer. But it takes a little bit more arithmetic than going to the one that's already solved for length. But it does work. For triangles, one of the things that you need to bring to the table is if it's talking about angles, you have to recognize that in a triangle, the angles add up to 180 degrees. And then I always draw pictures. You saw the picture of the rectangle on the last one. Here's a triangle. The smallest angle in a triangle is half the largest. So it's, I might pick the one that looks the largest and pick the one that looks the smallest to me, just so it's a little more representative. And so here the smallest is half the largest. The other way to have done that is that the largest would be twice the smallest. So you could also say y is twice the smallest. Just, you have options. The third angle is 15 less than largest. So this is your third. And it is 15 less than largest. The largest was y. So we have everything in terms of y now. So the x, this third angle here, plus the y, which is your largest, plus the z, which in this case is your smallest here, equals 180 degrees. So again, this is the x, the y, and the z, 3 angles. We can get rid of the fraction right away by multiplying everything by 2. Or you could clean it up a bit more first if you prefer. Half of 2 is 1, so that just becomes y. 2, 4, 5 y's. Add 30. Divide by 5. And that becomes 78. And so now, because everything else was in terms of y, you can actually quickly plug it in and find the values for these other angles. Again, this first one here was 78. This one is going to be the 78 minus 15. 63. And this one is half of y. Half of the 78. Half of 78 is 39. And so there you have your three angles, 78, 63, and 39. Be careful in XYZ that you put it in the order that they request. I think they say from smallest to largest. So basically the important thing is that you are substituting in so you get an equation with just one unknown so you can solve for that. So Carly, what was starting to confuse you? Are you talking about the triangle problem? Oh, she's gone again. She keeps coming and going. Let's see. And Frank, welcome. Can you hear me?
Yes.
Okay. Do you have any questions about this section 2? What was it? What are we on? 2.3, the application one?
No.
Okay.
Nope.
I did put up an announcement with some hints about the fence problem that's in the homework. So take a look at that if you need help on that. You know, sometimes understanding the situation is a little bit hard. Drawing out a picture can really help. So, but I did put a announcement about questions. I think it was 5 and 9 in this section.
Okay.
Did you have any questions on 2.1 or 2.2 before we move on, just to catch you up?
No, I'm fine.
Okay. So 2.4 is on linear inequalities and interval notation. And so when you're solving an inequality, it's like solving an equation. The only difference with an inequality, do either of you know the difference when you're solving an inequality? What you have to pay attention to?
No, I'm not sure.
Okay. So when you're solving an inequality, you need to switch the inequality symbol if you multiply or divide by a negative. Does that sound familiar?
Yes, that does.
So if you multiply or divide by a negative, then you must switch the inequality symbol. The other thing that we pay attention to with inequalities is some notation. So an open dot is used when you have a strict inequality, so less than or greater than. And you use a closed dot when it's less than or equal to or greater than or equal to. Additionally, we sometimes need to, you know, when you're going greater than something or less than something, you might get to infinity or negative infinity, keeps going. And so those kind of are similar to an open dot, it's not included. So when we do interval notation, which is going to be maybe new, is it new to you guys? Have you guys seen an interval notation before?
For me, it's been about 2 years, but I have seen it.
Okay. And Frank, have you seen interval notation?
Yes.
Awesome. Okay, so maybe I don't need to go into as much detail, but probably doesn't hurt to do a little review. So interval notation, oops, my flash drive keeps being recognized and not being recognized. There we go. So smallest to largest, and you either use a bracket or parenthesis to indicate whether it's included or not included. So brackets are when it needs to be included, and that's when you have a closed dot. And parentheses are used when it is excluded. And those are the open dots, or positive or negative infinity. So you use closed dots when you have, or use the brackets when you have a closed dot, and parentheses when you have that open dot. If it's negative infinity, it will be on the left because that's the smallest you can go, or, and then some number. And then you'll have a smaller thing, comma, infinity is the largest you can go, and then parenthesis. So that's kind of the idea with infinities. So just quick review on this. Open dot, so you'd use a parenthesis or bracket.
Open dot is parenthesis.
Okay. And then the smallest value is 3. The largest is 7. Open or closed dot? Closed, so you
Closed dot would be a bracket.
Good.
Okay. It's all coming back.
And then on number 2, it keeps going. It's a little hard to see because it's overlapping here, but it's an open dot here, and it keeps going to the left. So what is the smallest it can be?
Negative infinity?
Yep. And the largest?
1.
And what would we use here, bracket or parenthesis?
That I think is a I don't know. I don't want to guess. I was going to say parentheses.
It is, yeah. Parentheses
Okay.
can include it. It doesn't exist, you know, it's a concept, not a number. You can't actually touch it and include it because it keeps moving further.
Okay.
And then on the
Okay.
right-hand side, it would be a,
Bracket.
this is an
I'm sorry, a parenthesis.
parentheses. So again, parentheses are for excluding, so it has the infinities as well as anything that would have an open dot.
Okay.
All right, so there's some other cases we'll see later, but let me just kind of throw this out at you guys. What if I had something that looked like that? So we have 2 pieces. So we take it and we say we have this piece, and so the and in math, there's a symbol for it. It's the union. So this is going to go to negative infinity, and parenthesis for infinity or negative infinity, up to negative 2, open dots, so parenthesis, united or merged with, together with 5, and this time we're going to use a
Bracket.
because it's filled in, comma, it's going to infinity. So then we use a
parenthesis.
Yep. So that's how you do them if they're disjoint. You use the little U, and same in the
Okay.
computer program, you'll use a U.
Okay.
Can you guys hear over my daughter?
Yeah, we can. I can.
Good. All right, so I don't normally put in the 0. Some teachers do. I feel like then there's another number to go like where or what, how do I put that in? So I just always do the reference number. And you need to know the inequality symbols. So if you don't review it yourself, less than or equal to, greater than or equal to. So if it's less than, it's not including it because it's strictly less than. Less than are numbers to the right, like 4, 3, 2, etc. And so the interval notation for that. And then on the last page, I didn't do it, but it did ask, you know, for the inequality notation. So you can see there's the inequality notation, there's the interval notation. And if I were to do, let me go back to this one. If I were to do the interval notation, it looks like this, but the inequality notation for a disjoint thing like this would be x is less than -2, or you'd use the word or, and you'd write that in the computer. X is greater than or equal to 5. And on a problem where it's just a segment in between two things, you could do it in two ways. You could say x is greater than 3, and it has to be greater than 3, and it has to be less than or equal to 7. A more efficient way of dealing with and is to basically say it's less than or equal to this. In this case, it's equal because of the filled in. And greater than 3, read it this way. And so it's between 3 and 7. 3 is less than x, and it's less than or equal to 7. So that would be the inequality notation and the interval notation. All right, let's look at a few more special cases just to remind you of a few important things with inequalities. So I'm dividing by -2 here. So when you multiply or divide by negative, don't forget to switch the inequality symbol. If you're dividing by 2, you're dividing by a positive, so it does not switch here. Even though you have a negative, what you're dividing by is positive. Here, you might want to switch both sides, and when you switch the side, you switch the inequality. So in other words, you're reading it this way. 3 is greater than x, well, x is less than 3. And lastly, here's one of those ones where it's already a composite. It's showing the two endpoints. You can separate it into thinking about this inequality and this inequality and finding the overlap. I'll do it that way. To start, so -5 and 2. So x is greater than or equal to -5. And x has to be less than 2. So and it has to meet both criteria. So where you're meeting both criteria is right in here. And so ultimately your graph is going to be, so that's like your scratch work graph. It's going to be between -5 and 2. Anything in between here, like 0, is greater than -5 and less than 2. And so that interval notation would have the bracket here and the parenthesis there. The alternative is just to recognize that this is a composite, and here's the smallest, here's the biggest. This has a solid line underneath, so it's going to be the bracket. This does not have the equal part underneath, so it's a parenthesis. All right, so that's kind of what I have kind of planned out to mention about 2.4. Let me take a quick look with you guys at the computer. This thing's in my way. How do I get? Okay, 2.4. And again, there's these worksheets. Hopefully you guys are doing the pre-homework section, looking it over. There's that this is pretty close. Actually, I think this is the exact one I just projected to you guys and worked on. It's not always like that. And then answers, so you can check your own work and make sure you're on the right track. Because of ADA accessibility, I don't always have like it worked out like that. Normally, it'll just have an answer key with the answers, but not necessarily the work. And you're welcome to inquire on any that you don't get right as to what you're doing incorrectly. All right, I'm just going through here. 2.3. Oh, there's that fence problem. I had there's a rectangle problem, but I was noticing that not only did I put it as an announcement, I ended up adding it to the lesson as well. Okay, so here's the interval notation. You can see that I posted a worksheet with practice. It's practice not only for solving inequalities, it's also practice on you know, solving equations really, and graphing. And you can practice your interval notation if you want to on these as well. You just need to check with me if it's correct. Or, oh yeah, I actually ended up putting it down here for the inequality so that you guys could practice inequality stuff. I just typed it up. So then we get into the homework. And so set builder is, you know, basically it's the set, which we talked about in chapter 1, set of X such that, and then here is the interval using an inequality. So in this case, it's pretty much repeating what was given to us because there was no solving necessary. And then the interval notation, again, I think it's easier to do these from a graph personally. So I'm going to go to 3 with an open dot. And unfortunately, you might need to, depending on your screen, make it visible. Okay, so put an open dot there and greater than, and go with one smoothing until you get your arrow. Don't start like going over it or going, oh, I missed a piece. Oh, I need to get this piece and go over it, because it will mark it wrong if you do something like that where you went over it, because it doesn't see it as one answer. It sees it as multiple answers. So nice, smooth action. All right, and then the smallest you have is 3. The largest you have is infinity. I used my keyboard there, but I could have also gone here to the interval and used, in this case, parentheses and bracket, or type that in and use the infinities here. There's that union if you have 2 disjoint segments. Again, looking at the preview, yeah, that's what I intended to write. Submit, I got it right. Let's take a quick look at some others. Multiplying here by a negative. Let's see. Multiplying here by a negative 3 over 2. What you do on one side, you do on the other. That becomes positive. Because you multiply by a negative, you're going to switch that inequality symbol. The negatives cross cancel, or negative times negative is positive. 2 and 10 make 5, so you end up with 15. Again, positive, because negative times negative is positive. Inequality changed. So this one will also be an open dot and also go to the right. And I'll need to clear because I didn't have enough of the screen showing to go all the way to the end. Oops, I didn't do all of it, so then it didn't give me credit for this, but it gave me credit for that. Interval notation, similar to what we just did, 15 with parenthesis, comma, infinity. Infinity can be done with 2 zeros. No, sorry, not zeros, O's. The letter O. All right, I think that is close to it, just similar to the ones with equations. Multiply by 100 to clear those decimals. I think there's some with fractions where you can use the LCD, so multiplying by 6 to get rid of both the 3 and the 2. So it's like, I want to get rid of the division, so I'm going to multiply. I need to get rid of the 3 that's being divided and the 2 that's being divided, so I might as well just do 6 instead of writing it times 3 and times 2. So times 6, and then distribute that to each term and solve from there. And then here you can see some of these are not nice integers, so they broke it down for you to help you enter it into the system. And then here, evaluate, so that means plug it in for the x, solve, so undo addition or subtraction, undo multiplication or division. Is 0 a solution? So plug it in and see if you have a true statement. That makes it a solution. And then solve this, which you already did here, so you don't need to resolve it. You just need to write the interval notation. Let me clear that again. So I find it easier, less mistakes happen if I go ahead and distribute and then get rid of the fractions. But if you are comfortable with distributive property and how that works, you can go to this term and then to that term. And don't go to each thing in the parentheses because those aren't terms. This was a term. So if you do that shorthand way, just be careful that you don't overly multiply by 6. And again, they have written examples. So here they show that you're going to multiply by the LCD and that this 5 minus a is left. It's just that when you multiply by 15, that becomes 3a. When you multiply by 15, you're going to have 5, and then both then get distributed later. I think that's pretty much it for this. Let me double check. Yep. And again, don't forget to distribute the sign with you, so -2 gets distributed. All right, and then 2.5 is the last section. Let's see, I need to get back to this. And that is on intersection and union, and just a couple words about that. So union is like the U-shaped one. The intersection is kind of like the N of intersection. And when you have the union, you're uniting or merging. You're putting them together. You're joining them. The intersection is where they overlap, what they have in common. So I think about Venn diagrams. The union would be all of this, and the intersection would just be what they had in common. So let's do one with the sets, and then 1 or 2 with the inequalities. And I think what I'll do for the sake of time as well is just project and discuss. If you have questions, let me know. So union, so we're going to merge them. We're uniting these two. We typically do it in order. So we have 2, 3, 4, 6. You don't need to mention twice, 9, 12, and 15. So all of these elements are here now because we've merged them together into one set. The intersection, what do we have in both of these? What's in common? And that's just the 6. If there would be nothing in common, we would state that, and you'll see that down lower. So then for inequalities, draw the situation and think about whether it's an or an and, or they may use the intersection or the union symbol. So merging is this thing or that thing, so it meets one or the other criteria. So again, union, you might want to think of that as the word or, and the intersection as the word and. So when I did greater than or equal to 3, and here less than 1, when I merge them together, it literally is that, and I represent it with the disjoint with the union in between. This next one, when I go to merge them, because they were going in opposite directions and had some overlap, and I merge them together, we end up having everything is graphed at some point or another. So it's all real numbers, negative infinity to infinity with interval notation. Here's another or, but they're going the same direction. So it's either this or it's this. So when I combine these two together, merge them together, I get from 5 on. Imagine this kind of slips down here. And then here, also union symbol being used, again, merging, and it's an open dot here, so but then it gets closed up right there. So it's from 7 on. The ands or the overlaps, the intersections, it could be that there's no intersection, so there's my scratch work, but when I look at the intersection, there isn't any, so that would be my final graph and my solution. Where they're intersecting is when they're in opposite directions is right here. So there's my scratch work graph and my final answer. And then here's one with the word and again, where the overlap is between there. So I hope that that gets you guys started on the week 2, or gets you kind of finishing or wherever you're at, helps you with your week 2 homework. You can see again, smallest to largest. You can actually solve it without splitting it up into 2 equations, or you can split it up and look for the overlap. Just make sure you have the word and when it's connected like that. And then here's another one just to work with the LCD, but we've done a couple problems like that now, so not as important, but again, you can do it to each thing all in one instead of breaking it up if you prefer. So if there's any other questions, I'm happy to stay and work with you guys individually on any of your specific questions.
I'm good. I do have one question. Are you going to be doing this type of thing regularly?
Yeah,
Like every Tuesday. Okay.
From
awesome.
6 to 7.
Okay.
And then I'm trying to record them and post them. I did not get the posting up. I thought it did it automatically, but it apparently not. So I don't have week 1s up there, but I will in the future have them up there.
Okay, awesome. Thank you so much.
You're welcome.
Yeah, I'm good too.
Great. All right. Good luck with week 2.
Thank you.
Bye.
All right, thank you. Have a good night. Bye-bye.
You too. Bye-bye.